Good morning, viewer. Welcome to our perspective. Here's the breaking news. Yes, our brain. Our brains have been linked to an orchestra with neurons as musicians creating a symphony of thought and memory. A recent study reveals the conductor behind this symphony, electric fields. These fields are generated by the combined electrical activity of neurons, orchestrating them into functional networks. This research shines a light on the brain's complex inner workings and could impact the future of brain-computer interface. Electric fields generated by the collective electrical activity of neurons coordinated information across key brain regions. The process is made possible by a mechanism called epileptic coupling, which can influence the spiking of neurons and thus their signaling to other neurons. Findings could improve our ability to read information from the brain and have implications for the design of brain control. The circuit metaphor of the brain is as indisputable as its familiar. Neurons forge direct physical connections to create functional networks, for instance, to store memories or produce thoughts. But the metaphor is also incomplete. What drives these circuits and network to come together? New evidence suggests that at least some of this coordination comes from the new study in cerebral cortex shows that as animals played working memory games, the information about what they were remembering was coordinated across two key brain regions by the electric field that emerged from the underlying electrical activity of all participating neurons. The field in turn appeared to drive the neural activity or the fluctuation of voltage apparent. If the neurons are musicians in an orchestra, the brain regions are their sections and the memory is the music they produce. The study's authors said then the electric field is the conductor. The physical mechanism by which this prevailing electric field influences the membrane voltage of constituent neurons is called effective coupling. Those membrane voltages are fundamental to brain activity. When they cross a threshold, neurons spike, sending an electrical transmission that signals other neurons across connections called synapses. But any amount of electrical activity could contribute to prevailing electric field, which also influences that spike, says study senior author Al K. Miller, Peak Hour professor of the Department of Brain and Cognitive Science at MIT. Beyond the report, Fosak TV.